Marc, Missey. I'm a full stack developer at Vivo. It's that music video company that you see all over YouTube. Yes. A lot of people don't realize that we also have our own apps and website. So I work mostly on the website and some other JavaScript related projects. Yeah. So let's get started. Home voice assistants are super hot right now. Amazon's got the Echo Dot, the Echo Show has a screen. Google has Google Home. Apple's got their HomePod coming out soon. And those devices have found a niche market for hands-free voice assistant type of things, so you can ask what the weather is, or to read your calendar, do things like control your light switches and your thermostat. And so being a web developer, I thought it would be really interesting to try and figure out how I could build apps for these devices. Since I already had an Echo Dot, that was the obvious starting point. So for this talk, I will talk you guys through building an OS skill that hits the Slack API. So a little bit of background. I don't know if you guys are part of the Denver Devs Slack team. I'm sure a lot of you are. Dave, one of the volunteers, runs it. Drew and myself and a few other people are admins on this Slack team. And so you know that we don't pay for it. So we use the free tier of Slack, and one of the problems with the free tier is that it only allows you 10,000 messages in your history. So that's been fine for the past few years, but as we continue to grow bigger and bigger, that has become kind of an issue. Our chat history goes away pretty quickly. Here's some graphs showing our growth and the messages that we use. We're sent around 1.2 million messages ever, and which comes out to around 95,000 per month or 24,000 per week. So that means with our 10,000 message limit that we really only have a couple days before our messages go away. I think that's another graph on here too. It's interesting to see that, it's kind of hard to read, but the purple line there is, the top right, the top left is where messages are read. And the purple line is public channels. So like 87% of all the messages that we read are on public channels. But the second chart shows where they're sent. And 58% of messages sent are in DMs. So a lot of times you'll end up where there hasn't even been a lot of chat in the public channels, but yet that history is being deleted. So I had the idea to be able to archive some of those chats. Sometimes we have some really good conversations, sometimes they're really bad, but sometimes we have some good conversations, especially in like topic career advice or help CSS, help JS. Some of those actually helpful channels. I really like the React channel. So the idea is to build a Slack app or Slack bot that can archive those conversations. And since I have Alexa Dot on my desk, I figured that I might as well make it Alexa trigger. So this problem is something that we've been calling heat death. As we gain more and more users, and we're at 3,200 now, around 3,300, and as we gain more and more, the time period of those messages gets shorter and shorter in our history. So to make this Slack Alexa bot. Here are some of the first ideas that I had for features. I wanted to be able to archive important conversations, and then just do some general administrative tasks like get information about the team, set my do not disturb on or off, check for my unknown messages, and then since I was already messing with the Slack API, I figured why not send alerts like at channels, because I know how much everyone loves at channels, and or kick and invite users to and from channels. So the first step was to check out the Slack API and see what it's capable of. Luckily, Slack API is super powerful. Just about everything you can do in the client, you can do using the Slack API. So the first thing to do is to get a legacy token. The reason I got a legacy token is because since we're using the free tier of Slack, we only have 10 integrations available, and those are all full. But if we use a legacy token, we can just hit the API directly and don't have to worry about taking up more slots in the integrations. One thing to remember with tokens is not to commit them to GitHub ever. I made the mistake of doing that, and Slack emailed me almost immediately and said, hey, we saw our token on GitHub, it's revoked. So it was commented out, I missed it, I knew that I was supposed to commit that. So, getting started creating the skill. You can't really see these screenshots too well, but this is the Slack Alexa SDK, the skills kit. And so you just go to, I think it's developer, here's the link, developer.amazon.com. You can click on the Alexa skills set, and then just create a new skill, or start a new skill. And from there, you just fill out a really easy form. It's got name and invocation name, so what you want it to say, what you want the user to be able to say, so you get that invocation started so that Alexa will respond. After that, it goes into the interaction builder. The interaction model builder is also pretty simple. It's got three main parts. There are intents, which are the tasks or the triggers that you want your skill to respond to. There are slots, which are the variables that you want the user to be able to give to those intents. And then there's utterances, which are the phrases that the user might say to trigger the intents. So the first thing to do is set up those intents. So for this one, say that the save transcript intent. This is really blurred. That's not that important. So you set up the intent, you give it a name. And this one is called save transcript, and then you give it utterances. So I have like make a new transcript, or make a transcript for 5 hours, make a topic random transcript for 3 days. And that's where I add in the slots. Let me see if I can open up the actual Alexa dev console so you can see this stuff a little clearer. So you add in intents and slots, and for save transcript, I said we have intents like, or utterances like save a transcript for duration, of channel name for duration. We're going to get this open now. So you go to Alexa skills kit, like I said, different stuff here. So, in the Alexa skills kit, this does not have my skill. Okay. So when you go to the Alexa skills kit, I said you start by just filling in these, the name and location name, and then when you hit next, it goes into the interaction builder. Let's do this. In here, you can add in intents, like save transcript, and then you put in all the utterances that you might want to say. And so you want to use a lot of different methods or a lot of different phrases that the user might say in order to trigger this intent. So I have save a transcription, make a duration long transcription, save a channeling transcript, make a transcript for save a duration, whatever. So the slots, like I said, are the variables. This one is, there's two slots here. This is channeling and duration. Channeling is a custom slot. The slot type is channeling. And duration is a built-in slot called Amazon duration. So that's any period of time. You can say 3 days, 2 minutes, 5 years, anything like that. And it gets converted to this ISO format. This is a standard that I didn't know about previous to this, but there's a node library or an NPM package that I was able to pull in to convert that into actual timestamps. So for each of these slots, there's options here as well. So if I select, is this slot required to fulfill the intent, which of course a channeling is for saving the transcription, then Alexa will be able to say, or if I say save a transcript and I don't give it to channeling, then Alexa will ask for which channel, and that's what I put in here under one of the prompts. And utterances here is what the user might say back to fulfill that slot, to fill in that slot. Duration is the same way. So, one of the problems that I had with channeling is that Alexa can't just pick up any phrase that you say, or at least it won't match very well. So I had to make this custom slot type of channeling and input all of the channels that we have. But of course, as a programmer, I didn't want to do that all by hand. So I wrote a script to do that. And this is a super simple script that just hits the Slack API, gets the channel list, and then creates this JSON. It has the channel ID, so I can use it for API calls later, and then it puts in the name, the actual name. And then I add in some synonyms, so I replace any dashes with a space. So topic random with a space will map to topic random. And I also replace help and topic with nothing, so that help CSS will map to just CSS also. So now I don't know where I'm at in my slides. Here. Okay. Oh, so the next step is creating the skill. Let's do a regular so we don't know what a lambda is. Lambdas are these event-driven functions as a service. So the cool thing about them is that you don't have to worry about setting up servers and keeping servers running all the time and dealing with any of that pain for all the server uptime. They're completely on demand. They only spin up when the events that you have fire. And so the lambda will spin up, and as soon as it's finished, it will shut down. So they're super scalable, on demand, and they're really cheap. The first 1 million invocations to your lambdas are free, as if on a free tier of AWS. And after that, I think it's like 0.00002 cents per 100 milliseconds that they run. They're really cool because they're executable from a variety of events. Like you can have it on API database, so when someone hits this, hits a URL, it'll fire the lambda. Or when S3 image is uploaded, or something happens in the database, or timed events, or anything like that. One of the issues is that they are stateless, so you can't save anything from the lambda unless you use some sort of other structure for that. So like a database or write to a flat file, I guess, if you want to do that. So you can totally create lambdas just using AWS's GUI. And I did that when I first started working with AWS. I was working on a project for work, and I I didn't really know a whole lot about AWS and all the different types of resources, so I did most of it. I set it all up by hand. But I quickly realized that if I was going to deploy the same thing to development environment, staging environment, and production, and then the infrastructure had to be the same for all three of those, that this just wasn't going to work. Having different environment variables and making sure everything was mapped correctly was a huge pain. So enter serverless. Serverless is a framework for event-driven functions as a service, and the serverless framework allows you to deploy to any cloud platform that has these event-driven functions, like AWS, Google Cloud, Azure, IBM, OpenWest. So setting up serverless is super simple. You just install it using npm. You have it build up a template. This one is for AWS Node.js. And then you add in your credentials, which means you have to sign into AWS and create a new user for serverless. And then give it administrator access, grab that key and secret, and then put it into your serverless config. And that's it. Next is serverless.yaml, which is probably not readable. But this is my entire serverless.yaml. It's 59 lines. And this file allows us to, this is basically the CloudFormation template for AWS. It's the script for exactly what needs to be set up. So we have service, which is obvious, it's the name. Then I've got some custom environment variables here, a bucket name for my S3 bucket and a topic for SNS messaging. I'll show you later. Some provider information when we use AWS in Node 6.1. And then the IAM role statements, which all of the lambdas that are in this project will run using this IAM role. So I give this role access to all of S3, S3 nuts, or S3 star for my bucket at least. And then I give it permission to publish using SNS with my custom, whatever it is, topic. And this function here is join, it's like a CloudFormation join. I don't really understand it, I copied it. And so here are my two functions. We've got one named DB Alexa, which is the main Alexa handler, and it's got a handler function. So this means that it calls, in the handler file, it calls the function called handle event. I've got some environment variables that are passed into it, and this lambda is triggered using an Alexa skill. I've got the second lambda on here as well. It's called DB transcript. Here's the handler, its environment variables, and this event is fired from SNS. It's short or simple notification service in S3 or in AWS. And I'll show you that a little bit of that in a minute. And then finally, we just have the resources that we need. So this is just an S3 bucket that I set up using my custom environment variable. So that's all there really is to setting up serverless. And then you just, I've got a custom deploy script for it because I wanted to make sure that I export my Slack API key so that I can have that in my environment variables without uploading it to GitHub again. And then the second line here, I use the AWS command line to upload my style sheet to S3 because since we're going to have transcriptions that are HTML, I want to make sure that they've got CSS and they actually look nice. And then you just run SLS deploy or serverless deploy, and this all happens really quickly. And so where are we at now? So we have set up our Alexa skill, put in intents and utterances and slots, and we set up our lambdas and we deployed them to AWS, but they're empty, so we have to do some coding. Here's an event, a lambda event handler is relatively simple. It just takes 3 arguments, event, context, and callback. The event is the event data for who, how, and what was called. Context is some runtime context, like it'll tell you how long you have until the timeout, because you can set how long the lambda can run until a timeout. And then the callback is how to respond to the caller. I don't know if these are readable at all. But this is a simple handle. This is the main handler for the Alexa, the first And so the main three things here are, it switches through the request type. It might be a launch request, or an intent request, or a session name request. So a launch request is like, Alexa, open Denver Devs. Is my speaker now? Alexa, open Denver Devs. Alexa, open Denver Devs.
Welcome to Denver Devs, Alexa. How can I help?
And then, if you don't respond, there is
Send a message. How many members do we have? Do not disturb on raw. Make a transcription. How many messages do I have? Or kick users.
And then if I say cancel,
Thank you for trying Denver Devs, Alexa.
that would be a session end request. The middle part, intent requests, that is my all the tasks that I want to handle. So it's basically just a big switch statement where I check which intent was called and then call different handlers. This is the handler for kicking users. So what I did here is I just check the slot, or get the slot response. So I just dig into the JSON, I pull out the channel information from the slot type, which was channel name, grab the ID. Next, if there was no ID, that's when that checkbox to fulfill, required to fulfill the intent, that's when that comes into play. So if there's no channel ID, it means that slot's not there. So I just call back with a dialog element, and that will have an effect like Alexa, kick users. That's not gonna work. Cancel. Alexa, tell Denver Devs to kick the users.
Denver Devs has 3,244 members.
Oh, that's a different intent, but sure. But anyway, it will it'll give you the prompt. It'll tell you it'll ask you for which channel. And so the callbacks for Alexa are mostly using this build speech response function, which is just some simple JSON. Output speech can be two types. It can be plain text or SSML. SSML is speech synthesis markup language. So you can have Alexa have emphasis on certain words or spell things out instead of reading them, pronounce things differently, or whisper. The card type is what shows up on your companion app on your phone. And there's a couple of different ones there. There's simple and standard. Standard allows you to add in an image. So here I have a Denver Devs image that gets put in there. And then the read prompt text is that thing you heard when she started to say, you can say this or you can say that. So the card response looks like this. It's got basically the same stuff that I told, or that I had Alexa read back to me. So then, like I said, the transcription lambda is different from the original DD Alexa lambda. The reason that I split out that task into a different lambda is for a few reasons. One, I wanted to be able to parallelize it. So you might want to make a transcription of every channel all at the same time. So this way, you can just spawn up a bunch of lambdas and have them all make transcripts at the same time. The other reason was, well, I wanted to be able to show a different type of event for this talk. So sending an SMS message is really simple. You just use the AWS SDK. There's a node or an NPM package for that. And so I set up some JSON here with the arguments that I want to send to that, and then I just hit publish. And so on the transcription end, the event looks like this. It has records, and it says SMS here, and you can see here, it has the message information that I passed in. So I have a channel ID, and then the oldest timestamp. So that's going back how long. And so for the transcription lambda, these are the things that we want to be able to do. So we grab all of the JSON for the messages, and then for each message we have to do a lot of text parsing. You have to pull out usernames and the username and user information for the author, and any mentioned users, because the JSON that you get back from the Slack API, it's all has IDs. So it says, you know, this user ID sent a message to this user ID and mentioned this channel ID. So you want to be able to put that into a readable format. So this is a chunk of code where it's just a promise string where I pull out, I just chain them all together and pull out the correct information. And then after all of those promises are finished, I reverse them and join them because they come in the opposite order. They come in from newest to oldest, and you want to display it in the correct time. And add some day markers, and then I just basically concatenate a bunch of strings. This function, get user info, is one that I like because this is a pattern that I like to use. I don't know what you call it, I guess promise memoization or something. I have a user lookup object that is empty. And as I call get user info, if it's in that lookup object, I just return that lookup object, the promise resolve, or else I fetch that, I make that API call. But I also set the lookup object equal to that promise that comes back from the API call. That way, if I call for the same user's information 5 times, the 4 following ones will get the promise, and so all 5 of them are listening to the same promise response. So I find this pattern pretty useful for that. And then the second function is just string concatenation for making a message. Uploading to S3 is just as simple as sending an SMS message. You just use the AWS SDK to call .upload, pass it in the body of the HTML that you want, and a few other parameters here. ACL is like for the rights. I don't know what ACL stands for, but I want it to be able to be publicly read and publicly accessible. And then we end up with a transcript that looks something like this. I think this is topic help or something. And then we send a transcription receipt, which, so that everyone can access the, let's see, okay. So that anyone in the room can see that this transcription has been made, and we can reference it later. So to test these skills, Amazon's got this little utility where you can enter in utterances, like I could say, make a transcript of help.js for the past 5 days, and I'm able to see the request and the response down below. Or there's a voice simulator up top where I can type in what I want Alexa to say and use SSML, use plain text, and then be able to hear how she would read it. So that's really helpful. The other way to troubleshoot is to look at your logs. Everything that you output in a Lambda log ends up in CloudWatch. So a lot of times, if I couldn't figure out what a bug was, I would just put a console log in and deploy it and then test it, because Alexa doesn't give you any good information on the device. It just says the requested skills response was unexpected or something. So I would go into CloudWatch and check it, so you can see like this duration, P5D, which means 5 days. And, yeah, so this is really helpful for being able to debug. I think next. So what's next? Things that I might want to add to these lambdas would be like a better transcription text parsing. There's some things that the client does for Slack that I don't have in my transcriptions. Bold italics, code formatting, emojis, threads for everyone to put in here. Better utterances and better speaking flow so that Alexa can better understand what you mean and call the right intent. More SSML responses so that Alexa sounds better as you respond. Sometimes questions, they end up really high, and it's kind of confusing. Slack has a real-time messaging API, which is nice. So we could potentially tie in and have real-time archiving, which would be cool. And I'd also like to build a better front end for displaying the transcripts. But at that point, with those two, you kind of end up just building a whole new Slack line. So I don't know if that's really necessary. Oh, and Alexa now has these notifications, and you can drop in on other users or send people messages, and so you get like a yellow ring around the device when you have a notification. And so I think it'd be really cool to be able to have that light up when you get a DM in Slack, so you know when you got a new message. So I think next is demo time. I don't have any notes, so hopefully I remember what all that. So I can say things like open Denver, or Alexa, open Denver Devs.
Welcome to Denver Devs. How can I help?
Turn do not disturb on.
Do not disturb turned on for 8 hours.
Alexa, tell Denver Devs to turn do not disturb off.
What channel should I post to?
Cancel.
Thank you for trying Denver Devs, Alexa.
Alexa, turn do not disturb, cancel. Forgot. You have to say,
Do not disturb is already turned off.
I don't know how she knew I meant Denver Devs. Okay. Alexa, how many messages do I have? This is the admin account, so it's a ton.
No messages from today. For earlier ones, go to the Alexa app.
I keep forgetting to say Denver Devs. Alexa, ask Denver Devs how many messages I have.
You have 6,779 unread public channel messages.
Let's see what else we do. Alexa, send an at channel to general. Cancel. I didn't say Denver Devs. Alexa, tell Denver Devs to send an at channel to general.
What is your message?
At channel.
Message sent to general.
Everyone's going to go back right there.
This is not.
Yeah, I got a knot as well.
It says not at channel.
It just says not.
This is not a single word knot.
Little slides. Okay. Alexa, save a transcript.
I'm not sure.
Keep forgetting to say Denver Devs. Alexa, tell Denver Devs to save a transcript.
Welcome to Denver Devs, Alexa. How can I help?
Of course, this is good. Save a transcript.
You can say send a message. How many members do we have? Do not disturb on raw. Make a transcription. How many messages do I have? Or kick users.
Save a transcript.
For which channel?
Topic random.
Going back how long?
5 days.
The transcription has been started for topic random.
So I'm going to see a transcript in here. You can go in. This is not 5 days. Must have been like 5 hours or something. It's weather now, isn't it? I don't know. Anyway. Back to my slides. What else? So I can
Pretty echoey too. I think that's gotta be.
oh, that might be it.
Also, my Alexa doesn't listen to me at home,
So,
Alexa and Siri's way worse than that.
so then finally, I have one more Alexa intent on here. Cancel. Alexa, tell Denver Devs to burn it down. It's working on a lot.
Instant skills response.
Did it just pick everyone?
Yeah, random.
I picked from. Oh, so it worked on the smaller channel. It did not work on the large one because there's just way too many people. And I think. So that's it. Now I have Of course there's. Is that right? Accounts utils, functions do this. So I can't undo it. Syntax error here. See a syntax error? But I do need to make sure that I grab this line. Let's put that. Oops. My undo script doesn't work. Wonderful. I don't even know what that syntax error is. Constant skills. You see a syntax error? I see a syntax error. Let's switch these to double quotes. Oops. What can I do? I can do this using just nodes. Let's see if this blows up. Good. There we go. So hopefully Denver does at least has 240 users.
Let's go.
Did I actually kick anybody out?
No, you got a hand front.
Okay.
Then one person does.
Okay. Well, that's it. We have a slide for questions too. But, any questions?
How long did it take you start to finish to do all of this, you think, number of hours?
Number of hours? Okay, so we had July 3rd off, and I spent all day there. And then weekends, and sometime after hours. Total hours, I don't know, 20-ish? Maybe more. Lots of debugging. 25.
Can you talk a little bit about how like serverless also lets you share code with your lambdas and like standard things that you wouldn't be able to do?
Oh,
with
yeah,
lambdas?
absolutely. Very good question. This is my team lead. Eva. Yeah, so, I don't know where my slides went. Here they are. So, one of the really cool things about serverless is since the, I guess I can just do it with So in the serverless.yaml, since everything is kind of self-contained, and the package that gets uploaded to AWS is the same package for this whole thing, you can reuse a lot of your code between lambdas. So all these utility functions that I have, so fetching Slack endpoints and converting around time, getting the Slack responses, all those utilities are reused. Here's my secret response to Barton and all. She didn't say anything though. She's supposed to play it. Well, audio play. She actually busy trying to remove everyone from random. There's like 2,700 people. So with serverless, you can reuse go pretty easily between lambdas. And so, I know at Vivo we use lambdas for a bunch of our microservices, and we just pull in our own little libraries all over the place to cover most of the boilerplate type stuff. So that could be really, really helpful. Serverless just makes lambdas and deploying and everything super, super easy. Any other questions?
So your lambdas, are those written in Node?
Yeah.
Does this support other languages?
Oh, yeah, sure. So AWS Lambda supports Node, Python, and I think Java. There are a couple of ways to use other languages like Go, or even going with other languages. I don't really know how to do that. Are you stuck with Node?
How do you handle authentication? It's like you're using an admin account, so where does that get authenticated?
So I just grab a legacy token from the Slack website, and
So like anyone that had that skill could
if I included that in GitHub, but I didn't. So you have to deploy your Lambda. So with my deploy script here, I don't want to show you. I don't want to have the access token recorded on the camera. But the deploy script allows you to, well, first I set the environment variables, and then I tell serverless to use that environment variable as the Lambda environment variable. So then it gets pulled in. So when I switched it from my legacy token to the admin legacy token, so that I wouldn't have 200 or 2,000 people all messaging me when I kicked them out. That's how I did it. Just switch the environment variable.
So that token would be there for anyone that got the service?
Anyone on our Slack group, I believe, can just go and get a token, or maybe just request a token.
You have to deploy your own Lambda and use the skill.
Oh, so this skill is not a public skill right now. If I wanted to publish this into the skills, how would I do authentication? I'd have to do Lincoln account linking. So there's another part of Alexa that allows you to have users link accounts. And so I'd have to tie in with Slack and link their accounts so that I can get their Slack token and then use that for everything else.
So how do you companion that?
Yeah, so a card pops up that shows you, it says like, please link your account when you sign in using Slack. And then I believe Amazon or Alexa somehow has access to that account and can get the token from there. I haven't tried that yet. Anything else? Who's your one? Okay. Well.
Would you find yourself making more Alexa skills?
Yeah, totally. And it all depends on the idea. The reason I made this one was mostly for transcriptions. Really business. Yeah. Oh, so I was answering your question. Would I make more skills? Yeah, if I had a good idea, I would totally make another skill. I didn't take it, but I don't have the ideas. This was really just for the talk. I was like, hey, what can I do?
Do you use it often?
The Alexa in general, or the skill?
Yeah, the Alexa.
Sometimes this is an Alexa talk, but I feel like I would get more use out of Google because Google knows more about my life. But Alexa is definitely useful for hooking up to media stuff. I use it for home automation stuff, my lights and thermostat, the weather, the news. But I don't have a whole lot of skills that are really super necessary.
Now you've gone through this, you kind of got the base, we're talking about the time. What do you think to develop a new skill, now you've gone through that, what do you guys think it would take?
I mean,
If it's a relatively simple one.
sure. So the hardest part, I think the thing that I spent the most time on was the transcription stuff, which was, it doesn't really have anything to do with Alexa so much as it was just difficult coding, parsing all that information out, making all of those different API calls, and a lot of it I wasn't testing locally. You know, you can put in a fake event, you can test that all locally, but I was mostly deploying and then testing, so that added a little bit of time also. One thing that I would definitely do is add linting, because there's a lot of times where I deployed stuff, and Alexa would give me an error and go into the log and say, oh, you forgot a close parameter or something. And so linting would stop me from having all of those poor deploys.
You had to send your Amazon AWS login to serverless, right?
Kind of. So the Alexa Skills Kit, this developer.amazon, is different than AWS. In AWS, they had to do, and then I had two different sites. I don't know what the period is for Alexa. But I had to go into AIM, which is the identity access management, creating a user for serverless. Role. And then I got a token and a key for that, and then next up is just like serverless config, whatever.
Are there any security concerns with that since it has admin access?
I mean, I could mess something up personally from my machine, but I don't think that I'm not worried about serverless as a company or as a group also sending that config to themselves. I think it's all contained on my machine. It pulls from, I think it's like in your home directory, you've got AWS or something like that.
Oh, so it's local?
Yeah.
Okay.
It's my actual AWS config on my local machine. I think serverless just made it an easier way to set that all up personally. Yep.
How has the show changed how developers would approach it, or what Amazon provides for developers?
With the Echo Show, which is the one with the screen on it, obviously it becomes a lot more visual. So there are other options for card responses and for responses back to the user that have a lot of visual elements to them. So you can have more than just a small picture and a little bit of text. You can play media, I think, and audio and other stuff all directly there, but I haven't really played with the shows they don't have. But I think it just makes everything a lot more visually centered, which is what I would expect from a new device with a screen. That's it. Thanks a lot.